And welcome to review day 3. Today we're going to take a look at probability. So specifically the topics we learned are the 3 different types of probability, which is experimental or empirical. That's where you perform the experiment yourself or do a survey and get results. Theoretical is based on laws and formulas, and subjective probability is based on intuition like a weather forecaster. We then looked at the difference between probability and odds. Odds, remember, is the probability of an event happening over the probability of it not happening. Okay? Whereas that's, I apologize. So that's the odds equals, right? Okay? Whereas probability of event happening equals the probability of the event, so number of A, over the total number in the sample. Okay? Okay? All right. So, folks, just to make sure, I want to clear that up. I think it should be the number of A versus the number of not A, not the probability. So, I apologize for that. So, number of A divided by the number of not A. Okay? All right, so taking a look at probability and counting techniques, we took a look at being able to do different types of techniques to put things in order, and we're going to come back to using combinations and permutations with that. We took a look at if they are independent or dependent events or mutually exclusive events and how to treat them. For example, I speed when I'm in a hurry. Okay, so one's dependent on the other. All right, so we're still going to follow the prom theme, and here we go with example number 1. There were 132 tickets sold for prom, 46 couples tickets were bought, and 12 people went on a carriage ride. Four of the couples went on a carriage ride. If a prom goer was picked at random, state the probability of picking a person from a couple. So, question A, when we're taking a look at what our event is picking a person from a couple. Okay, so taking a look at that, okay, remember our formula for probabilities. Probability of A equals the number of A divided by the number in the sample. Okay, so, well, let's take a look. Number in the sample, we know how many total tickets are there, 132, so I can do the bottom part first. And then, how many couple tickets were there? Well, there was 46 couple tickets, but because each one is a couple, you got to times it by 2. So that's going to be 92 over 132. Okay, plug that in your calculator, you get 0.6969 repeating. So that equals a roughly 70%. Okay, so what does that mean? That means that, therefore, okay, there is a 70% chance of picking a person from a couple. Okay, let's take a look at question B. The odds against picking a carriage rider. So odds against, you got to be careful here. Okay, so our event B, just to change it up, okay, because A was already up there. So event B is picking a carriage rider. Okay. So we want odds against. Okay? So odds against B equals the number of not B, or B prime, to the number of B. So remember, it's the opposite because it says against. Okay? All right? So the number of people, well, first of all, the number of carriage riders we know is 12. Okay? Out of a total of 132, so take 132, subtract 12 to give you your 120, which means there's 120 not going. Okay? And for odds, we like to leave it in a ratio. Okay? And so if we put it in lowest terms, it's going to be 10 to 1. If you're not sure where we got the number of B prime, you take the number in the total, subtract the number of carriage riders, which equals 120, just in case you forget that. It's a little side margin there. All right, let's take a look at C. C says the probability of picking a person from a couple given that they are a carriage rider. So again, we've got to take a look at this because it's a little different formula. So probability of A given B. Okay, so that equals the probability of A and B over the probability of B. Okay, so how do we figure out the probability of A and B? Okay, well, taking a look here, it says that there's 4 couples that went on the carriage ride, so 4 times 2 over a total, which is 132. Okay, so that's going to equal 8 over 32. Don't worry about lowest terms because we're going to plug it in the calculator or in the formula after. So that's okay if it's not reduced here. If it's not your final answer. Okay, and the probability of B, okay, is going to be 12 because there are 12 people on the carriage ride over 132. Okay, so to plug this in, we're going to say that's going to be 8 over 132 divided by 12 over 132. Use the fraction button on your calculator, or remember that you take the first fraction, you invert and multiply the second one, if you're not sure about how to do this. Okay, and the 132s will cancel, and you can simplify, so this will equal 8 over 12, put that in lowest terms, which equals 2 over 3, and because most probabilities are changed to a percent, that's going to be 66.7%. Okay? So, therefore, 66.7% chance that picking a person from a couple will be a rider, carriage rider. Okay? All right, let's see, one more problem I think down here. Good. Are the 2 events mutually exclusive, and then are they independent? Okay. Well, first of all, when we talk about mutually exclusive, if they're mutually exclusive, the Venn diagram would have to look like this, where there's no overlap, okay? But what we know is that there are some people who are couples that are carriage riders. So is this mutually exclusive? No, okay? So it is not mutually exclusive. Because if we took a look at our Venn diagram, we know that some of the couples are also carriage riders. Okay, so no, not mutually exclusive because there is an overlap between carriage riders and couples. Okay, so that's why they're not mutually exclusive. Okay, that's the first one. Now the second one, how do we test to see if it's independent or not? Okay, so if we want to test for independence, okay, what does that tell us? That the probability of A and B has to equal the probability of A times the probability of B. Okay, if we're going to test if they're dependent, okay, then we have to take a look at probability of A and B equals the probability of B times the probability of A given B. Okay, so it's one dependent on the other. We'll have to take a look. All right, so the first thing I want to do, excuse me, is take a look at what do we know? From this first statement in independent, we know the probability of A because we calculated it above, okay? And the probability of a person being a couple, okay, was the 69.99%. So probability of A equals about 70%. So 0.6969 repeated. Okay, and if we take a look at independent here, folks, we take a look, what do we know that we've calculated? We've calculated that the probability of A given B is 0.666, repeating, which we just calculated in C. Okay, and remember, folks, if we take a look at these formulas to test to see if they're independent, well, both formulas have the probability of B in them, okay? But what we have to take a look for are, does probability of A equal the probability of A given B? Okay, and they do not equal, so you say no, because they're not the same, because we've got 69.69 here and 667. So they're close, but they're not equal. So since probability of A does not equal probability of A given B, therefore it is not independent, since probability changes, or probabilities are not the same, therefore dependent. Okay. All right. Moving on to another example. Example 2. Okay, there are 12 people on the prom committee. Mrs. Smith randomly selected 4 people to get gift certificates as a thank you. What's the probability that Brandy wins a gift card but Marissa does not? Okay. Well, let's take a look at that. So first of all, what's our main event? Our main event is that that Brandy wins. Sorry. And Marissa does not. Okay. So the number of ways that this can happen is if we select Brandy and because we don't want Marissa, there are 3 other people. Which is not Marissa. Okay. I apologize, Brandy. I forgot to put a Y on your name. Okay. So, there is only one way you can choose Brandy is because you choose Brandy. And means to multiply. But how do we get 3 other people? Well, total is 12. Brandy's out, so that makes 11. But we can't choose Marissa, so that makes there's 10 others. And we're going to choose 3 of them. Okay. So plug that in, and you're going to know that that's 120 by plugging it in the calculator. So now we can figure this out. So probability of A equals the number of A over the number in our sample. Number of A, we already calculated as 120. Now how do we get the number in our sample? Well, how many total people are there? There's 12, and we have to choose 4. Okay. So that becomes 120 over 495, plug in your calculator, and you're going to get 24%. Okay, so therefore there's a 24% chance that Brandy wins and Marissa does not. Okay, all right. Question. Would it change your counting technique if the gift certificates were of different amounts? Well, if they're different amounts, like say one was 25, one was 20, one was 10, and one was 15, that would make a difference. So yes, that would change because order would be important, right? Because the first person would want to have the biggest prize value. Okay, and if order would matter, if order would matter, then you would use permutations, right? Instead of combinations. All right. All right, let's move on to number 3. Connor was a frustrating friend to have on prom night. He got a little carried away and was having trouble making decisions. He said he was only 80% sure that he was even going to go, and then only 75% sure he'd chip in for a handsome cab if he did go. He said that there's a 10% chance he'd chip in some money even if he didn't go. Okay, so what we need to take a look at is that these events, one event is dependent on the other. So let's take a look at the two events. So to define the events, event A is that Connor goes to prom. Okay, whereas event B is that Connor pays for cab. Okay. All right, so it says to create a probability tree diagram to help us. So this is where we're going to end up with two possible pathways. So we're going to start here. So we're going to say Connor goes. Okay, and then down here we're going to say Connor doesn't go. Okay, maybe he's been into too much of the pop and chips already. All right, so how do we figure that out, that percentage? We go back up to the problem. He was only 80% sure that he was even going. So 80% goes that he was going, and the complement of that is 20% that he's not going. Okay, now we're going to take a look at the second event, which is, so that was event A. Now we'll take a look at the second event B. Okay, so second event B, okay, is if he will pay or not. So pay, not pay. Pay, not pay. Then we've got to go back into the question to figure this out. Okay, so if we go back to the question, it said there was an 80% sure he was going, then only 75% he'd chip in. So if he's going, it's going to be a 75%, okay, which means the complement is 25%, okay? And then he said that there was a 10% chance he'd chip in if he wasn't going. So 10% goes here, and 90% goes here, okay? So the question, okay, so that was make a probability tree diagram. The second one is, what's the probability that he chips in for a handsome cab? So hopefully, let me see if I can put this in so you can see both of them. I made my diagram too small, so give me 1 sec. Can I move this up? Yeah, that'll help. Okay. Now we can get both of them on. So I'm going to try to get really colorful here with a highlighter. Hopefully it'll work. Okay, so there's two possible pathways he can go. He either goes and he chips in and pays, or he doesn't go, but he still chips in and pays. Okay, so we're going to figure that out. Okay, so hopefully I can leave that kind of there and write down here at the bottom. So the probability that he goes, which is B, equals the probability that of B given A, plus the probability that he pays even if he doesn't go. Okay, so let's just go over this terminology. So probability that he chips in for the cab is the probability that he chips in if he goes, plus the probability that he chips in if he doesn't go. That's what A prime means. Okay, so looking at your pathways there, okay, look at the top one first, or the yellow one. So it's going to equal 0.80 times 0.75. That's the top yellow path. Plus, let's do the blue path now. It's going to be 0.2. 0 times 0.10. Plug in your calculator, and it's going to be 0.62. So therefore, 62% chance that Connor will help pay for the cab. Okay. Awesome. Okay, folks, that is it for today for Review 3. Again, make sure you've got a study sheet, and if you need any help, come see me and work on those practice questions that are in the textbook. Okay? Have a great day, and see me for help. Ciao.